Welcome students to the chapter Chemical Bonding and Molecular Structure of class 11. Today we are going to see about the limitations of the octet rule or the Coastal-Lewis approach. So octet rule is itself the Coastal-Lewis approach. Limitations. What were the limitations of this approach? So first limitation was that certain compounds are known to be stable even if the central atom is not having octet. For example, lithium chloride. In lithium chloride, lithium is the central atom because it is the electropositive one or less electronegative one. So lithium does not have 8 electrons, it has just 2 electrons. So lithium is stable even without octet. So this atom without octet is called incomplete octet, means it has only 2 electrons. So there were molecules that are stable without octet. Clear? So lithium, which does not have octet, is an exemption from the Coastal-Lewis approach or the octet rule, which says that all the atoms want to be stable by achieving octet. So here lithium is stable without achieving the octet. So it is written here lithium in lithium chloride is stable just with 2 electrons. It does not have octet. Next is beryllium from the second group, alkaline earth metal. Beryllium, if you look, you can see that it has only 4 electrons. Still this compound is stable, that is BeH2. Beryllium in BeH2 is stable with 4 electrons. So again it is a violation from octet, that is beryllium which does not have octet, which is called as incomplete octet, because for octet it requires 4 more electrons. So even without that, this compound with beryllium 4 electrons is stable. Next is boron from group 13, boron family. You can see all rest of the molecules have, rest of the atoms in this molecule have octet, whereas boron has only 6 electron, a pair here, one on the top and one on the right side, so have only 6 electrons. So boron in boron trichloride is stable with 6 electrons. Again a case of incomplete octet. You will see more and more molecules, aluminium chloride for another instance. So there are molecules which are showing stability even if their atoms does not have the complete octet, which is called as incomplete octet. So that's the explanation here. Certain molecules are stable even if the central atom does not possess octet. So examples of such compounds, such molecules, all these molecules are examples along with aluminium chloride. Still there are more compounds, fluorides and so on of these atoms. So one thing what we can notice is that whenever the central atom has less than 4 valence electron, often they will show this exemption. What is the exemption? Incomplete octet of the central atom. So the name of limitation or name of exemption is incomplete octet of the central atom. So we have 5 or 6 exemptions to learn. So in that, the name of this exemption is incomplete octet of the central atom. And which type of atoms will show this? So it is the atoms which has a valence electrons of less than 4 normally show this type of exemption. Next, odd electron molecule, especially shown by nitrogen. Let us see here. Let us see how many electrons does nitrogen have. Just try to count it. So 1, 2, 3 pairs, which means 6 electron, and 1 odd number electron, which means that N in nitric oxide is having 7 electron. So the name is nitric oxide. The compound name is nitric oxide. In the compound nitric oxide, oxygen is having 8, but nitrogen is having 7. And this type of incomplete octet, this is also an example for incomplete octet, but not a real example. This is classified as odd electron molecule. Clear? So this is classified as an odd electron molecule. in which nitrogen atom has an odd number of electrons, that is 7 electron. Similar is the case with nitrogen dioxide. So in nitrogen dioxide 2 have an incomplete octet, but this type of incomplete octet with odd number of electrons is termed as odd electron molecule. These compounds are stable but reactive. As soon as they see some other molecule, they will react. They are classified as free radicals, which we will learn later. Clear? So nitric oxide and nitrogen dioxide, what type of exemptions does it show? It shows odd electron molecule exemption from octet rule. So it's written here, certain molecules contain odd number of electrons around the central atom and does not possess octet. Such molecules show this type of exemption, that is odd electron molecule exemption. Third one is expanded octet. As you can see, there are three examples: PF5, SF6, H2S4. So expanded octet means more than 8 electrons for the central atom. In the case of phosphorus, if you count the number of electrons for phosphorus, starting from here 1, 2, 3, 4, 5, which means that there are 10 electrons shared by phosphorus. 10 electron means it is more than octet. So phosphorus has 10 electrons. In these molecules, if you are counting 1, 2, 3, 4, 5, 6, 6 pair of bond pairs, which means that, and here also 1, 2, 3, 4, 5, 6. 6 pair of electrons means there are total of 12 electrons, much higher than the octet. All these compounds are highly stable compounds, which means that octet is not the criteria. So again, elements beyond third period. Third period means if you are looking into this sulfur, it is in the fourth period. No, it is in the third period. Clear? So in the first period we have no elements. In the second period we have oxygen, and in the third period sulfur. Similar is the case with phosphorus. It is from the third period. So third or beyond that, heavier elements have d orbitals. So using that d orbitals, they can make more bonds, more bond pairs. So octet is limited to certain molecules. There are many molecules that are not showing octet for their stability. So in that way, it is a big limitation. But one thing we have to accept, octet rule is applicable for large number of molecules. Still, many molecules shows exemption from it. Clear? So this is three main exemptions, and rest of exemptions we will see other exemptions. So basis of Kossel-Lewis approach was the stability of noble gases. Stability of noble gases, because of their octet they are known to be stable. But later it was found that noble gases to react with other compounds to react with other atoms to form compounds. അപ്പം KL approachന്റെ basis എന്തായിരുന്നു? noble gasന്റെ stability ആയിരുന്നു. But later they have found that noble gases to reacts and forms compounds like this: XCF2, xenon difluoride, xenon oxofluorides. So these type of compounds are formed, which again contradicts the stability that is proposed by the octet rule. Next exemption, KL approach does not account for the shape of the molecule. What does that mean? Later it was discovered that each molecule possesses definite geometry. So water has a geometry, oxygen has a geometry, methane has a geometry. All the molecules that is existing, that is stable, has a definite geometry. Geometry means shape, a three-dimensional shape, fixed shape for water, fixed shape for methane, fixed shape for ethene, which could not be explained by this KL approach. And the final one is, it does not account for the stability of the molecule, which means that why are certain compounds very reactive and others are not. So it just mentioned about the stability of certain molecules. It did not mention or did not compare the stability. Okay, one molecule is stable, but it is more reactive than the other molecule. Why is it so? Such questions could not be answered by KL approach. So to summarize, incomplete octet shown by the molecules or the atoms having valence less than 4, they often show it. That means not all, they often show this incomplete octet of the central metal atom. And odd electron, especially nitrogen, nitric oxide and nitrogen dioxide, they have odd electrons, 7 electrons in their molecule. And expanded octet, which means that more than 8 electrons. Molecules having, atoms having in a molecule, sometimes atom is having more than 8 electrons. In all these cases, it is the central atom that is showing this type of exemption. And finally, the last 3 noble gases were shown to be reactive, which we saw. Then geometry of the molecule could not be predicted. And finally, stability of the molecules was not explained. Why is certain stable compounds are stable, why are not certain stable? Clear? So this is about the limitations of octet rule. Thank you.